Good morning, class. This is the second part of the lab. So we are going to be working with motors and electrical controls. It's a unit one, day one is a lab. This is the second objective. So the student should be learning how to determine the gauge of the feeder and branch circuit, the gauge of the feeder conductor and the conductor on the branch circuit. So here what we have is three electrical motors. Each of them is a three-phase electrical motor, 5 horsepower, 7 horsepower, 3 horsepower. The three of them are connected to 480 three-phase, okay, panel. So we have the three-phase here, three-phase. So, and this is my distribution panel, and I have my protection here. Okay, and I have the three conductors that will be feeding up my three electrical motors. Okay, so the first step is determine the full load ampacity. Which table do I use to determine this? Full load ampacity. Three-phase electrical motor, so I need to use the table 420.250. 420.50. That is the table that I need to use, okay? To determine right here, NEC table 420.250. Okay, so according to this table, for the first motor at the left, 5 horsepower, the full load ampacity is 7.6 amps. For the second motor from the left, 7.5 horsepower, the full load ampacity is 11 amps. For the third one, the full load ampacity is 4.8 ampere, and we have it here, okay? And all of them are three-phase and squirrel cage motors, okay? So the short circuit protecting device, okay, we need to calculate the 250% of the smaller motor amperage, which is the smaller is 4.8 full load ampacity, and we multiply it times 4.5. Keep in mind, I was explaining you on the previous one that to convert this into factor, which is 250%, we divide it by 100 and we remove the percentage sign, which is 2.5. So calculate the 250% of the smallest full load ampacity. In this case is 12 amps. So I use the protecting device. I round it to the nearest higher one, which is 15 amps. Then the branch circuit conductor ampacity, the 125% of the full load ampacity of the largest motor. Then I add all of them, the 125% of the largest one. So in this case, my largest one is 11. So I multiply this by 1.25 and I add the other two for a total of 26.15 amps. Okay, 26.15 amps. If I am using to determine the gauge, okay, let me put it here, the gauge, American wide gauge. So if I am using the NEC 2017, the table is 310.15 parenthesis B parenthesis 16. If I am using the NEC 2020, the table is 310.16, okay, to determine the American wire gauge. So if I use that table, and I know that it's 26 amps, okay, the table, let me show you here, the 310, because I have the 2020. So it will be the 310.16. 310 310.16. Okay, 310.16. 310.16, that is the table, okay? So for 15 amps, for 26, 15 amps, okay, I use gauge 12. Okay, so gauge 12. So the branch circuit conductor will be gauge 12. Okay, and this will be gauge 12. Gauge 12. Okay, and that is what I need to use, okay, for the feeder. And of course, right here, the branch, this is the feeder, okay? But the branch, 7.6 amps, I can use, well, gauge 12 as well, okay? Because gauge 14 will be okay on all of these, but I will go by gauge 12, okay, THHN. Okay, and that is the second part of the lab, how to determine the gauge of the gauge, the size of the feeder conductors and the branch conductors, okay? So thank you. Don't forget, this is based on the NEC. And we are learning and practicing how to use tables NEC 480.250 for three-phase electrical motor, and table 420.52 in order to determine the short circuit, the rating of my fuse, the short circuit protection, okay, and we can use, of course, these are three-phase, but there are other tables for single-phase electrical motor, the 420.248. Let me show you these tables, so you can be 420. 420. $250, okay? So what I will do, let me